Alright, let's dive into something that's both mind-blowing and a little underappreciated: the upcoming solar eclipse on August 12th and the insane amount of science happening behind the scenes. Personally, I think this is one of those moments where astronomy and technology collide in a way that's just chef's kiss. But here's the kicker: it's not just about watching the moon block the sun. What makes this really interesting is how scientists are using supercomputers to predict the behavior of the solar corona, the sun's outer atmosphere, with jaw-dropping precision. So, the Instituto de Astrofísica de Canarias, IAC, and Predictive Science Inc, PSI, teamed up to simulate the corona's structure during the eclipse. Why does this matter? Well, the corona is this mysterious, superheated halo around the sun, reaching temperatures of millions of degrees Celsius, while the sun's surface is a mere 6,000 degrees Celsius. In my opinion, this temperature discrepancy, known as the coronal heating problem, is one of the biggest unsolved mysteries in solar physics. And this eclipse? It's a rare chance to test our models against reality. Here's where it gets wild. They're using the Palma Supercomputer to solve magnetohydrodynamic, MHD, equations, basically, the physics of how magnetic fields shape the corona. What many people don't realize is that the corona's structure is entirely dictated by the sun's magnetic field, which is constantly changing. So, scientists are stitching together observations from satellites like NASA's SDO and ESA's Solar Orbiter to create a 3D map of the sun's magnetic field. It's like putting together a puzzle while the pieces keep moving. But why go through all this trouble? From my perspective, it's not just about predicting what the corona will look like during the eclipse, though that's pretty cool. It's about understanding how the corona works. This isn't just academic curiosity. The corona's magnetic structures drive solar storms, which can knock out satellites, disrupt power grids, and mess with GPS. So, if we can crack the code on coronal heating, we are not just solving a scientific mystery, we are improving space weather forecasting. Now, let's talk about the NATE project, which is taking this to the next level. NATE stands for North African Telescope Eclipse, and it's a collaboration between Spain, Morocco, and the US to observe the corona during this eclipse and the 2027 eclipse in Morocco. What's fascinating here is the focus on citizen science. They're training students and teachers to operate telescopes, turning this into a global educational effort. One thing that immediately stands out is how this project bridges science and community, making astronomy accessible to people in rural areas and across continents. If you take a step back and think about it, this is science at its best: collaborative, interdisciplinary, and with a real-world impact. The IAC is even making their simulations publicly available on their website, so anyone can explore the predicted corona in real time. A detail I find fascinating is how they're using this eclipse as a test run for 2027, fine-tuning their methods and engaging the public along the way. What this really suggests is that eclipses aren't just celestial events, they're opportunities. Opportunities to test our models, to inspire the next generation of scientists, and to remind us how much we still have to learn about the sun. Personally, I can't wait to see the images from Palencia and compare them to the predictions. Will the models hold up? What new insights will we gain? This raises a deeper question: how often do we get a chance to witness science in action like this? It's not just about the data, it's about the process, the collaboration, and the sheer wonder of it all. So, here's my closing thought: whether you're in the path of totality or just following along online, take a moment to appreciate the science behind the spectacle. Because this eclipse? It's not just a shadow, it's a spotlight on the mysteries of our universe.